Most people think Russia's power begins with its military. They're looking in the wrong place. The system that shaped Eurasian geopolitics doesn't fly through the sky or sail across the sea. It runs silently beneath forests, frozen tundra, mountains, rivers, and thousands of kilometers of open land. A hidden network so vast that much of the world depends on it without ever seeing it. And once you understand how this underground system works, Russia's role on the global stage begins to look completely different. Russia holds some of the largest natural gas reserves on Earth. But possessing resources has never been the real advantage. Many countries have energy. Far fewer have the infrastructure to move enormous volumes across an entire continent. That hidden transportation system transformed underground resources into long-term geopolitical influence. The story began decades ago. During the Soviet era, engineers constructed one of history's most ambitious pipeline networks. Thousands of kilometers of steel stretched across Eurasia, connecting remote production fields with industrial regions hundreds and sometimes thousands of kilometers away. Political systems changed. The infrastructure remained, and many of those corridors continued shaping regional energy flows long after the Cold War ended. But pipelines are only the visible layer. Beneath every transmission corridor operates an enormous support network. Compressor stations maintain pressure. Monitoring centers track performance around the clock. Maintenance crews inspect remote sections year-round. Control systems coordinate operations across immense distances. Without this hidden infrastructure, the entire network would stop. Geography makes the challenge even greater. Routes cross dense forests, massive rivers, mountain ranges, marshlands, and permanently frozen ground. Each environment requires different engineering solutions, turning every kilometer into a technical achievement rather than simply another stretch of pipeline. For decades, Western corridors supplied major European markets. Meanwhile, Eastern routes expanded connections with growing Asian economies. Instead of pointing in only one direction, the network gradually evolved into multiple strategic corridors, serving different regions across Eurasia. That flexibility became one of its defining strengths. Infrastructure of this scale cannot operate without protection. Remote facilities require access roads, inspection teams, surveillance systems, emergency response capabilities, and continuous maintenance. Much of this activity happens far from cities, largely unnoticed by the outside world. Yet it keeps one of the world's largest energy systems functioning every day. The pipelines do not stand alone. Railways deliver heavy equipment. Roads connect maintenance bases. Ports support exports. Industrial facilities process raw resources before distribution. Together they form an interconnected logistics ecosystem rather than a collection of isolated projects. Every component strengthens the others. Far to the north, another chapter emerged. Arctic production expanded the frontier of energy development. Extreme weather, sea ice, and long supply lines demanded entirely new approaches to engineering and logistics. The result was an even broader infrastructure network, stretching into some of Earth's harshest environments. As major transmission routes expanded, surrounding regions often changed as well. Industrial investment increased. Supporting industries developed. New infrastructure followed existing corridors. Over time, pipelines influenced far more than energy. They helped shape patterns of regional economic development. Internationally, pipeline infrastructure also became a foundation for long-term cooperation. Cross-border agreements, transit arrangements, technical coordination, and decades-long supply contracts connected multiple economies through shared infrastructure. These relationships often extended well beyond the energy sector itself. Keeping such a massive system operational requires advanced technology. Sensors constantly monitor pressure and flow. Remote control centers respond in real time. Automated valves isolate sections when necessary. Inspection tools travel inside pipelines, searching for tiny imperfections long before they become major problems. Much of this technology works quietly, hidden from public attention. Over time, global energy markets evolved. Countries diversified suppliers. New export routes appeared. Additional infrastructure projects changed regional energy patterns. Yet even as the landscape shifted, existing pipeline networks remained critical because replacing decades of infrastructure is neither simple nor quick. This is why the Eurasian pipeline shield is far more than a pipeline. It is an interconnected system of production fields, transmission corridors, industrial facilities, transportation networks, engineering, technology, and geography working together across extraordinary distances. Its scale is difficult to appreciate until you see every piece connected. Understanding Russia means looking beneath the surface. Headlines often focus on politics. Maps highlight borders. But infrastructure tells a deeper story. Because beneath the forests, frozen plains, and mountains lies a network built over generations, one that continues influencing economics, logistics, and regional planning across Eurasia. The future will undoubtedly change. New technologies will emerge. Energy markets will evolve. Supply chains will diversify. But geography does not move. Infrastructure built across continents continues shaping strategic possibilities long after construction ends. And that's why one of the world's most influential geopolitical stories remains largely invisible. Hidden beneath the ground,